Hi, welcome back. This is part 2 of the quantum model. So if you haven't watched part 1 yet, you need to go and watch part 1. And if you took a break between part 1 and part 2, don't forget to get your problem book out, page 215, 216, and 217, and follow along with us. So we are at the D sublevel of the quantum model. And let's take a look at that. So the D sublevel contains 5 orbitals. So remember, the S had 1 orbital, the P had 3, the D had 5. And also remember that the S had 1 lobe and the P had 2 lobes, and the D now has 4 lobes. At least most of them have 4 lobes. And all 5 orbitals are equal in energy, just like the 3p orbitals. And you don't get a d orbital until you reach energy level 3. So there's no 1d orbital or 2d orbital. You don't see them until you get to level 3. And this is what they look like. So notice, except for the one in the center, you get these 4 lobes, all right? And this, even though there's 4 parts to it, are not 4 orbitals. This whole thing is 1 orbital. This whole thing is 1 orbital, and this whole thing is 1 orbital. And each orbital, so this right here is 1 orbital, can hold 2 electrons. This can hold 2, this can hold 2, this can hold 2, this can hold 2. So together they hold 10 orbitals. So let's go back to that program so we can see how the 5d orbitals look like when they're all put together. So this would be 1 orbital, this would be another orbital, this would be another orbital. Each of these can hold 2 electrons. This would be another orbital. But what happens if they're all 5 together, which they would be, with the center being where the nucleus was? Look what happens when I add all 5 orbitals. It once again approximates a sphere. So this sphere of space is actually divided up into 5 orbitals, and each of those 5 orbitals can hold 2 electrons. Pretty fascinating. So individually, they have these odd shapes, but together they combine to form an approximate sphere. Now let's look at the F sublevel. But before we start giving you the information, see if you can figure out. So let's remember the S sublevel came in sets of 1, the P's came in sets of 3, the D's came in sets of 5. So before I show you, come in a set for F's. So write that down. S's had 1, P's had 3, D's had 5. What do F's come in? The other thing is how many lobes each of them have. The S really was 1 sphere, so 1 lobe, as we're calling that. The P's had 2 lobes for every orbital. The D's had, mostly of them had 4 lobes for every orbital. What do you think the F's come in? Well, hopefully you guessed correctly. Let's see what the answer was. The F sublevels come in 7 orbitals and have 8 lobes. Right, that was the right answer. The first principal energy level that has an F is the 4th energy level. So there's no F orbitals in the energy level 1 or 2 or 3. And here's what they look like. Although it's hard to see in these pictures that these are 8. You can see more in this picture that there are 8 lobes. So there are 8 lobes. So kind of some funny shapes to them. So let's see what happens if I put them all together. Because remember, if this is the nucleus, they are not side by side. They're actually all superimposed on each other. What does that look like? Here's that program again. So here are the individual, and I think you can see the lobes here. There are 8 lobes for most of these. There are the 8 lobes. 1, 2, 3, 4, 5, 6, 7, 8. And I bet you can figure out, or hopefully you can, so these ones are kind of odd with the circles. What happens if I put them all together? What do they approximate? So let's put them all together. And yes, indeed, they approximate a sphere. Pretty cool. And here's a picture of them all together. So this is the S, come in sets of 1, P's come in sets of 3, D's come in sets of 5, the S come in sets of 7. And this has 1 lobe, this has 2 lobes, this has, for most of them have 4, and for most of them, it's hard to see. You can see it better here, come in 8s. And why is there these mathematical patterns? Well, that's because these are answers to mathematical solutions of that Schrodinger equation. So let's review compared to Bohr. And here we have the energy levels, nice circles that they went around. That's not how it is, but the energy levels are the same. So in energy level 1, instead of this ring, we would have a sphere, which would be the s orbital. Energy level 2 would have 2 sublevels. It would have an s sublevel, which would be a bigger sphere, and then it would have 3 p orbitals, which would also be a sphere when you added them together. Then in the third energy level, you get s, p's, and d's. So notice the first energy level has 1 sublevel, the second has 2, the third has 3, the fourth has 4. And so now you have a sphere here for the s. You have 3 p's that are added together to be about a sphere, and the d's, the 5 d's that add together to be a sphere also. And then finally, in the fourth energy level, you have s, p, d's, and f's. So that's why it's much more complicated in the quantum model. So, atomic orbital summary. So, this is also in your chart, so you need to get out page 217 and fill this in. All right? So, and if you need to pause the video anytime while I'm filling in this chart kind of quickly, then pause it, catch up, and then play it again. So here we go. So in energy level 1, we have 1 sublevel, and that's the s's. And it is called the 1s orbital because the 1 stands for the first energy level and the s stands for the sublevel. The sublevel s also tells me the shape, which is spherical. And there is just 1 orbital per set for s's. And you can have 2 electrons. And so you have a total of 2 electrons in the first energy level. The second energy level, you get 2 sublevels. You get s's and p's. This is called the 2s orbital for the second energy level and the 2p orbital. In s's, you just have 1 orbital. P's come in sets of 3. For the number of electrons, you get 2 in the s's and 6 in the p's, so you get 8. This last column should be familiar to you. Those are Bohr's numbers. So now we have an explanation of why there's only 2 in the first and there's 8 in the second energy level. The third energy level, so hopefully you're seeing the pattern here, can have s's and p's and d's. And in the third energy level, they're called 3 s's and 3 p's and 3 d's. And s's come in sets of 1, p's come in sets of 3, d's come in sets of 5. Notice the regular patterns here. There are 2 electrons in the s's, 6 electrons in the p's, and 10 electrons altogether. And that's if they're all full. But this is the maximum they can hold. And notice we have 18 now. 10 plus 6 plus 2 is 18. And there we have Bohr's numbers. 2 in the first, 8 in the second, 18 in the third. And then the fourth energy level, we have s's and p's and d's and f's. And so we call these the 4s, the 4p, the 4d, and the 4f. And they come in sets of 1 and 3 and 5 and 7. And each of them can hold 2 electrons, so you get 2 and 6 and 10 and 14. And if you add all those numbers together, yes, you do get 32. So what does that all look like? Well, here's a little video that shows the orbitals and what they would look like all together. Here's the s and p orbitals. So in the middle, remember, would be the nucleus. So the 1s orbital is a sphere, and I'm not sure why it's coming in from the side, but there we have it. That's the 1s orbital, and it can hold 2 electrons. Here is the 2s orbital, and it's still a sphere, but it's a little bit bigger. So it kind of looks like Bohr's models, except spherical instead of 2-dimensional. And then the 2p's have these 2 lobes, and each of those 2p orbitals can hold 2 more electrons, and together they hold 6. And they're slowly coming in, and you can kind of see how the model is a little complicated to draw. So that's why some textbooks just show you the Bohr atom, but I don't like that because that makes you think that's what we currently believe when that is not true. So there you have the modern atom, at least part of it, with the s's and the p orbitals. What are the important points to remember in all this? Well, a maximum of 2 electrons can occupy a single orbital. The s orbitals are spherical, the p orbitals are 2-lobed, most d orbitals are 4-lobed, and most f orbitals are 8-lobed. That's the mathematical patterns we see. As the energy level increases, the orbitals get larger and their numbers increase. And by numbers increase, I mean for the first energy level, there is only one s orbital, but at the second energy level, you get both the s's and the p's. And the electrons in the higher energy levels are farther away from the nucleus. And the names of the sublevels tell you the energy level they are found in and the shape. So the names of the sublevels would be something like 1s, which would say the first energy level, and s tells you it's spherical. 2p tells you it's in the second energy level, and then it has the p-shaped, which is kind of like 2 lobes together. So there you have it, the quantum model. Hope you enjoyed this video, and special thanks to Mrs. Plata for making the PowerPoint. See you all in class.